Okay, we have to determine. Okay, so now we are, so if we look at the flow is coming from here, right? And we know that this is 35 times 10 to the power 3. Now, I'm not going to find a centroid. I'm just going to write for you. So we know that IZZ is equal to 0.270236 times 10 to the power 3. Okay, meter 4 or minus 3, sorry. And then Y bar is equal to 0.18676 inches from the top. Okay, from the top. So if you look at this problem, right? So if this is 250, I'm just going to sketch. The Y bar will be somewhere about here. Okay, so this is 125. So from here to here is 186.76. I'm going to show you what's the problem now. Okay, the problem is this. So if I'm going to sketch, this is 1. Okay. This is the other one. The thickness of them are 25. And the third one is over here, right? And then we have our fastener going through here. Okay, so we have our fastener going through here. And then we have our geometric centroid over here. So our geometric centroid somewhere around here. Okay. So remember, so if we were to design the shear flow, major web, this is how our shear flow will look like. And then failure will either occur here or failure will occur here. Okay. So this I call our left web. This I call our right web. And this is I call our major web. Okay. So now the problem is this. Okay. If we were to consider the right web, okay, we will consider the right web. Okay, what you can either consider the right or the what? Or the left. Okay, so consider, because the left and right are not related, right? So we can consider either the left or right webs. Okay, either one. Okay. So the problem comes is this. Okay, if you look, let's look at the right web. If we were to look at the right web, the area we have to consider is this area over here. And what's the problem? It crosses the what? It crosses the geometric centroid. Can you see that? Remember what we talked about? The first moment of area cannot cross the geometric centroid. But for this case, okay, in longitudinal shear, okay, in some cases, the first moment of area can cross the geometric centroid. Okay, for this case. Why? Because we have to obey the rules that what? We have to obey the rules that what? Remember the rules that's really important. The entire member must distribute the shear flow. Okay. So when that's the case, right, to calculate Q, you will take the entire right web. So the width is equal to 25. The depth is 250. Then the y bar, so y depth, the y bar is equal to what? Is equal to 186.76 minus by 250 divided by 2. Okay, so this will be equal to 186.76 minus 250 divided by 2 times by 250 times by 25. You get 386 times 10 to the power 3 millimeter cube, or 386 times 10 to the power minus 6 meter cube. Okay, so from over here, you know that Q is equal to V, which is equal to 35 times 10 to the power 3. And then the Q is equal to what? The Q is equal to 386 times 10 to the power 3. And then divide by I, which is equal to 0.270236 times 10 to the power minus 3. So this is equal to 35 power 3 times by 386 divided by 0.270236 power minus 3 is equal, syntax error. Divide by 0.270236 power minus 3 is equal to, sorry, rushing. 35 power 3 times 386 power minus 6, 0.0236 power minus 3 is equal to 50 times 10 to the power 3 Newton per meter. So the resistance force, because we only consider the right? So Q will be equal to the force divided by the distance, the spacing is 0.25. And you don't need to multiply by 2 because we only consider the what? The right. Okay. And this is equal to 50 times 10 to the power 3. The resistance force is equal to 50 power 3 is equal to 12.5 times 10 to the power 3 Newton. Okay. So yeah, this is the time where you have to break the rules. Okay. A special case. Okay. So in longitudinal shear, you can break the rule where the first moment of area cannot cross the centroid. That's all I have for today. I'll still stay behind with your question. Okay. Thank you.